So today we are going to design a video recommendation system from scratch. This video recommendation system is something which is commonly asked in interviews. So let's start off how we will be going to design this system. So initially we need to understand the objective of a video recommendation system. What are we going to design? What are the things that we already have in place? And what is the actual output that we need to give to the user? Okay. So initially, if you understand, this video recommendation system is nothing but something like your YouTube app or like your Instagram feed or your TikTok feed, something like that. So whenever you open your app and you see the feed which you are seeing is personally recommended to you. So we are gonna design a personalized home based feed, like a home page based feed, over which you can see all the videos which are relevant to you. And the things which we have right now is let's consider that we have around a billion videos. uh, Roughly, let's say we have 1 billion videos with us, which we already have in place, and somehow we are going to use them to train our model and finally reach to a point where we have a video recommendation system in place. Okay, so the objective is very clear, to design a system where we have videos which are relevant to us, relevant to a particular user. Okay, so the first thing in our video recommendation system is the objective which we need to clear, which is clear to us now. Second thing in a video recommendation system is we are going to break this problem into multiple parts. Second part will be what is going to be the input and what is going to be the output. So consider that the input is very simple here. The input is user itself. So for example, if you log in into your YouTube, so you are the input here, and the output which you are seeing here are the videos. So the input is user itself, and the output is going to be the videos. Now videos could be like, we can consider like K videos, where K could be like 50, 100 or 200, depending on like whatever the enterprise you are working for that wants you to be. Okay, now coming to the third part, which is kind of important part, like what is the data that you are going to have. Now let's discuss about the data here. Okay, so what data do I have? The first data that I have is like, okay, you are a user. So now let's think uh, that what data user can give us. So user can give us the age of user, the gender of user, the location of user, maybe the name of user, and an ID of user. ID could be something which our algo somehow, for example, if some user named Jatin is entering his credentials, so there is an ID generated for that particular user. So currently, let's say, okay, we have these user features, and we can just think of this right now. If we can add more features as well along the video as we go on, but currently, as we think of, these are something which I can think of right now. Now coming to the second part, where we have a video. Okay, so what things a video can have? Just think like, for example, if you are scrolling over YouTube, so what things does a video have? Video has a title, it has tags, then there are length of the video, then comes the views of the video, Then comes the you okay, you got title, tags, length of the video, views of the video, and I guess these are the things which generally you see in the video. There could be other things related to a video, such as language of the video, language of the video, and okay, I can think of this right now. So let's go ahead. Now let's think of some other data that we already have in place. That is the user video interaction. So what does that mean? So for example, as a user, if you think, what do you do with videos when you see them? Generally, a user can like a video. He can comment over a video. Third thing is that maybe he just watches the whole video. So watching the whole video. Fourth could be he just dislikes the video. There could be like other interactions as well. For example, consider the fact that, okay, let's say you went over YouTube and started searching multiple videos like cute dog videos and other few other examples. So here these videos these type of examples could be considered as a user video interaction, where you are using the search history to give more recommendations. So this is also a recommendation where, like, search history. Then yeah, this is what currently I can think of as a user video interaction. Okay. Now consider the fact that we have this data in place and we want to build a recommendation system, but currently we are not sure of how we are going to build that. But okay, we have something in place. We will break this problem into multiple parts. Okay, let's think about this breaking this problem into multiple parts of how can we extract features from our data. So first thing is that how are we gonna extract features? So this is the fourth part where we think about feature extraction. So feature extraction is nothing but taking the most important part from your from whatever data you have and representing into a form which our model can understand. Okay, so as I told you that we had user data. So what user data we had? Let's take that. We had age, we had gender, we have location, we have the name of the user and ID of the user as well. Okay, so consider the fact that, okay, age is there, then we have gender, then we have location, and then we have an ID associated with it. Okay. Now think, so can't we divide these ages into multiple age groups and use something like as one hot encoding? You can ask me that, how are you even thinking about this approach? So let's think. So let's divide this age groups into like 5 to 10, 10 to 17, 17 to 25, 25 to 34, 35 to 48, and 48 to, let's say, 72. So can't we just make 1 2 3 4 5 6 7 a 7 embedding vector, where, for example, if a user logins and he is of the age, let's say 18, he's of the age 18, so why can't we just represent his age like 0 0 1 0 0 0. So the age could be just a 7-dimensional vector. Okay, but how are we going to use it and what model we are going to use it? That's something which we will think on later stages, but eventually we can understand that everything has to be presented into a mathematical formulation so that model can understand. Like at the end, we have to give our model numbers, and this is the best way of giving our models a numbers. Okay, now we discussed about age. Now coming to the second part, that is video. No, sorry, gender. So again, gender just could be of three types: male, female, and other. So again, gender could be just represented using a three dimension vector. Okay, so this is also easy. So something like if a male who is who just logs in, he could be presented as 1 comma 0 comma 0. Okay, so this is also understood. Now coming to the point where we have location. Okay, so how many locations we can have? Consider that, okay, we have a lot of locations. We have like cities, multiple hundreds of cities, 200 cities. So why can't we just represent this location into like a 100 dim vector, like a 100 dimension vector? Though the quantity chosen could be really less, also you can represent it to like just like 10 embeddings or like 10 dimensional embedding vector or just like 5 dimensional embedding vector. It totally depends on you. But let's consider the fact that, okay, we are incorporating a logic where we are considering every particular city that is there in the world. So let's consider this a 100 dimensional vector. So a location could be, for example, if someone is from Mumbai, he could have a vector like 0 0.1, 0 0.2, minus 0.65, and it goes on, which are like 100 dims total. Okay. But how are we going to use this? That we will come on to later stages, that how are we eventually going to use all these things. Fourth thing. So then comes a point where we have something called as user ID. Every user will have some ID associated with it. Now, can't we just, the same way we represented our location, can't we just use some model and represent our user ID in a 32 dim vector or a 62 vector, 64 dim vector, whatever you prefer? Okay, but like, are there any other things which we can think of right now? Okay, let's think. Let's say the user logs in into a YouTube and he just watches Hindi videos or just watches English videos. So he has a preferred language, right? So it means that we can even choose preferred language as a entity. So preferred language could be again a 100 dim vector you can take off, because we are currently representing our language into a 100 dim vector. So a 100 dim vector. For example, if he's choosing Hindi, Hindi will have a 100 dim vector. Okay. Now coming to the sixth part, where let's consider the fact that the user will eventually like some videos. Okay, and maybe the videos he's liking are just short in length. Okay, so it means that the user prefers short content rather than long content. So even there could be entity where we can see that preferred time of watching content. So for example, it could be just like he just watches a video which is like roughly 10 minutes, not more than that. So now if you want to just represent time, so it's just pretty straightforward that it's just a number. And what you can do is that you can just represent it using one dim vector, one dimensional vector. Okay. What other user video interactions we have? So we can think of something like user goes and watches like 10 videos or searches about 10 videos on the search bar. So what you can do is that let's say user goes and searches for like 10 videos. Okay, and like every video will have some embedding vector in place. That is something which we will come later in picture, but let's consider that every video could be represented using a number, using a vector of, let's say, some 100 dimensional vector or something like that. So whenever a user is searching for these 10 videos, it means that the user wants to watch these videos, right? So if you are representing, let's say you're first searching for this 10 videos, so why can't I can just take these 10 videos, have 10 vectors for them, which I already will have, and just average them all out to make a common vector. So for example, let's say this vector was 3, 1, 2, dot 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 4, something like that, and it goes on and it goes on. So we'll just take an average of all of them and just form a vector. Okay, so this is again a interaction that happened between user and video. Then there could be a very simple user video interaction, such as that user went and liked a video. User went and liked the video. So why can't I just take the embedding of that particular thing and just concatenation? I'll just show you later how it works, but eventually why can't I just form a 100 dim vector? Let's consider that our videos are represented using, let's say, 100 dims. Okay, and eventually form a vector where we have all the list of liked videos. So for example, user liked 5 videos, and every video will have some embedding in it. 1, 2, 3, 4, 5, 2, 3, 4, 5, and eventually the thing is that everyone will have a embedding associated with it, and when we can just average them out again, just like we averaged the search video part. Okay, so these are some of the interactions which I can think of, and these are some of the things which I can use to make a user feature. Now what this user feature will look like, so let's consider that for every particular feature we took 1, 2, 3, 4, 5, 6, 7, why can't we just concatenate them all? So for example, the initially we had age. Now age was a 7 dim vector. Then we had gender, which was a 3 dim vector. Then we had something like preferred language, which let's consider that it's a 100 dim vector. Let's consider then what is the preferred length of the video he watches, which is a 1 dim vector. Then let's say he has a ID associated with it, which has a 32 dim vector. Then let's consider that the amount of videos he's searching is like 10 videos he searched, and eventually every video could be represented using a vector which has 100 dimensions in it. So it could be just like a 100 dim vector. So if you concatenate them all, so let's say whatever 110 210, 232, 233. So all the user features could be represented using a 233 dim vector. Okay, but now your question will be, are we what are we even going to use to make this 233 dim vector, and how eventually it will work? We will discuss about this later, but eventually you understand that how is the flow going, that we are breaking this problem to make sure that nothing is represented in English but everything is represented in numbers. So this is just a user feature. So as soon as some user logs in, for example, if let's say you are logging into YouTube, YouTube would be eventually making a user dim vector on the basis of, okay, let's say you watch two videos. They would be eventually making something like a 233 dim vector that would be helping YouTube to recommend more videos. Okay. Now coming to the part where uh, how are we taking care of these videos? Okay. How are we going to take care of these videos? Okay, so videos, what did videos have? Videos have title, they had tag, they had length, they had views, they had language. Yeah, this much I think this is what we covered. So again, we had title. So for example, the title is cute dog walking. So can't we use a normal encoder based model to represent this cute dog walking into a 32 dim vector or a 64 dim vector? Okay. And what about the tags? How are we going to use that? So for example, let's say the tags of the video are hashtag cute, hashtag dogs, hashtag sweet. So for example, for every particular tag, what we can do is that we can again convert this into an embedding. How are we going to convert this into a embedding? Will something which we will come later in the picture, but eventually let's say we convert this every particular tag into let's say a 100 dim vector. So for example, cute also has a 100 dim vector, dogs also have a 100 dim vector, and sweet also have a 100 dim vector. Okay. And then for just making sure that we are covering all the tags, we'll just take an average out of them. So, okay, so we are able to cover this also. Then coming to the length of the video. So for example, it's just pretty simple here. Length could be just like, let's say the video is 420 seconds long. The first thing is that you make sure to normalize it. How would you normalize it? It's just simply like 420 divided by there are 3600 seconds in an hour, so 3600, and whatever comes, let's say the value comes out to be it's something in points. Okay, now it's just a single number that is coming in place, right? So what does that mean? It means that we could just use a one-dimensional vector to represent anything, to represent any length of the video quantity. Okay. Now coming to the fourth part where we are having views. Okay. So let's say there is a really popular video. It has like 2 million views. Okay. Then we have a video which was just uploaded like 2 days ago, and it has just like, let's say, just 10k views. So there has to be a proper scale using which we can represent this particular views dimension. So what we can do is that, so we can just take a logarithmic of these views, 1 plus views, because the views could be 0 as well, and logarithmic of 0 is again undefined. So we need to make sure that we do log of 1 plus views. So again, if we take this, So let's consider that we have 10,000. So the eventually, and if we have a base 4, so it's just 4. Let's say we have a million, something like 10 lakh. And for this, it comes to be 6. So you see, now the numbers are at least comparable to each other. 4, 6, they are near to each other. Previously, what was happening was there was a video which had like 10,000 views, and there was a video which had like 2 lakh views. So again, the number of comparisons was like really large. So if we just keep these numbers as 2 million views, and if we use this data to train our model, then the model will just understand that every time I have to just show a video which has like really high number of views. It won't take care of low number of views. So we have to make this data comparable in nature. Okay. So eventually how we will be doing that is like this, to represent just into a single number. And if we are able to represent it to a single number, then we can just use a one dimensional vector to represent it. Okay. Then comes the last part where we have language. Okay. Again, the language of the video could be like English, Hindi, Marathi, Tamil, Telugu, or some other language. But to represent it, we can use the same stuff. We can just represent it into a 100-dimensional vector of our choice. Like we can just make a 100-dimensional vector, using which we can say that okay, if this 100-dimensional vector there is there, then it's Hindi. If some other 100-dimensional vector is there, we can use English. We can even use one-hot encoding as well. It's on our wish. So currently I'm just using a 100-dimensional vector. Okay, 100-dim vector. So again, like if you think now how a particular video could be presented. If we have a video, how a particular video could be represented. So the video could be presented using a vector where we have a title which is like 64 dimensions long. So it has 64 day in it. Then we have tag which is let's say 100 day minute. Then we have something called as length which is 1 day in nature. Then we have language which is like 100 dimensional. Then we have something called as views, which is again like 1 day in nature. So if you concatenate them all to just form a vector, so 200, 264 and 266. So it could be presented using a 266 dimensional vector. Okay. It's just a 266 dimensional vector. How it will be used and how we are even going to make the use of this, I'll just tell you later in this picture. Okay. Hope until whatever I have explained is clear to you. Now, let's think about how to the next part, that is the model development part. What model are we eventually going to use? This is one of the important parts, not the most important, but the important parts of machine learning system design. Okay, so but eventually, even before going to the model, we need to understand what category we are playing in. So we have a recommendation system that we are going to design. So generally, how it works is that for recommendation system, there are 3 types of it: content based filtering, there is collaborative based filtering, and then there is this hybrid based filtering. Okay, so what does this even mean? This content based filtering is nothing but it's like, for example, if a user watches just cute dog videos, then we will just recommend him cute dog videos. But don't you think there is a problem in this approach? That if a user is liking just cute dog videos and we are just showing him cute dog videos, then the problem is that he won't be able to see some diverse contents. For example, he could even see some WWE match or some other funny content, some stand-up comedy. He won't be recommended that. Okay, so this is a problem with content-based filtering. Now coming to the part of collaborative based filtering. Now what is this collaborative based filtering? Collaborative based filtering is simple, like if let's say user A and user B, if both of them are liking the same videos, so let's say user A liked video 1, video 2, video 3, and user B liked video 2, video 3, video 4. So why can't we make sure that the user A watches video 4 also? Because there are very high chances that user A and user B are very similar in nature, so they would like the videos which are liked by one of them. So we can show video 4 to user A and we can show video 1 to user B. Okay, this looks something better than content based filtering, but are there some drawbacks to it? There could be some drawbacks, something like, okay, so consider the fact that whenever a new user comes in, so how would you understand that what to show him, right? You won't be able to understand what should I even show to that user, because he hasn't liked any single video. So this collaborative based filtering will eventually fail. Okay, then what should we do? So then comes the approach which is content based filtering plus collaborative based filtering. That is called as hybrid based filtering. Okay, so what does that mean? Now in our model we'll be taking care of both, that is content based as well as collaborative based. Okay, understood. But how are we even taking care of that? That is something which we need to think of, and how a single model is going to take care of both the things, that is content based and collaborative based. Okay, so let's come to the model now. How the model should look like. The model should be a 2-tower neural network. Okay, what is this 2-tower neural network? So what we can use is that we can use 2 encoders. One encoder for user features and one encoder for video features. Okay, what does that mean, and eventually how it will look like? Let's try to understand this part. Okay, so I told you that user has a age, name, gender, then he has a language, some other properties associated with him, right? And video has title, tag, length of the video, views of the video, language of the video, and all that stuff associated with it. So why can't we use a user encoder, encoder based model, which would eventually convert all the features into a proper embedding vector which are contextual in nature. For every user, it will represent what are the likings and dislikings of that particular user. Okay, so it means that maybe what eventually how it will start is that we would have few one hot encoding vectors. For example, age could be one hot encoded already. Then your gender could be one hot encoded, but there are some things, for example your user ID, which could be directly sent into this user features and converted into a proper embedding vector, So which could be like 32 dim or 64 dim in nature. And eventually this encoder, what eventually at the end it should give us the output is a proper embedding vector, proper embedding vector which represents all the things about the user. Okay, but how are we even going to use that is something that we still have a doubt of. Then comes the video features. Can't we just use something like similar in nature with respect to whatever we used an encoder here, and we could use simple encoder here as well to represent all the all the video features in a embedding vector. Okay, but yeah, how are we even going to use it? How does it make sense? So okay, what data do we have? We have something like user one liked video, let's say XYZ, and he liked it. We have the interaction type, he liked it. We have user one, he have watched this video, uh, let's say 1 to 4, and he has watched like greater than 50%. Okay, so how can we use the data? Don't you think like if user one has this video and he has liked this data, so it means that this is a positive pair, means this is something like a label where liked means user one video XYZ and liked means 1, right? If a user is watching, let's say, a video which was more than 50%, so it means that somehow the user was quite attentive during that video and he was watching that video. So again, that could be represented as a label 1. So user 1 has a label 1 associated with it. Okay, so now you think that if we have this type of data and user 1 has this user features vector, and this video XYZ had this video feature vector, and eventually it comes down to a number that is 1 or 0. He likes it or he doesn't like it. 1 means that we are going to show it to the user, 0 means that we are not going to show it to the user. So don't you think it just becomes a classification problem at the end? Okay, so if it becomes a classification problem, then the solution to it is pretty simple. What we can do is that we have a two tower neural network where we have a user encoder which gives us user features vector. We have a video encoder which gives a video feature encoder. And now what should we do with them? These are just vectors, right? Can't we just do a dot product and get a magnitude out of them? We can do. So we just do a dot product to calculate similarity between them. So for example, we did a dot product between two, let's say this was user 1 and this was video XYZ, and we did a dot product and the number comes out to be 0.9. Okay, and the label associated to that was 1, and our probability or the number whatever came out to be also really high. So it means that this is just a classification problem where we are just classifying that the at the end between a user and a video, it should be a 1 or it should be a 0. Now, if this is a classification problem, what do you think the loss function should be here? It's pretty straightforward now. It should be binary cross entropy. Binary cross entropy loss. Okay. Now Coming to the part where we were saying that, hey, for this user one, we are liking this, there's this video XYZ and he had liked it. But don't you think we have 1 billion videos, and for a single user, if you just consider yourself, you go on YouTube, how many videos do you actually like? And how many videos you just don't see? So don't you think the data will be imbalanced here? Like there will be a lot of negative video, means a lot of videos, like for example in a billion data set, the user one will eventually just like, let's say 500 videos. Apart from that, everything is just a negative sample for him, like he is not even liking it, right? So this becomes a problem for it. So it means that this is an imbalanced data set, and if we train our data on an imbalanced data set, the data set will contain saying that user one video some random, like let's say, what I mean to say is that it could just say user one video number 324 and the user has disliked it, and this will be major, like major in number. Like for user one, he has even liked video 325, this is also 0. User 327, it should be also 0. And if this happens, the recommendation system will just give garbages to us. Like what is the point of recommendation system? That it won't give us anything, correct, right? So how do we take care of this imbalanced data set? Now for this particular thing, there is something called as negative sampling. Negative sampling, what does this negative sampling even mean? Okay, consider the fact that for every video which a user liked, user 1 liked a video XYZ. What we are going to do is that in the same batch, let's say there is a batch of, let's say 200 that we are going to train in the model. Okay, in the same batch, we are artificially going to generate this negative data, means negative samples. So for user 1, he did not even like video 324. So this label will be 0 for it. For user 1, he did not even like video 369. It will be 0 for it. But yeah, but how will it be useful? Okay, let's understand how will it be useful. If the user is not even liking or watching this video, it means that these videos have not to be recommended at all. So at least the feature vector that will be formed after a training, it will hold the contextual information that, okay, at least I don't have to recommend the user these videos. Okay, and here if you see, the data also doesn't remain imbalanced, because for every one positive samples, we just generate 50 negative samples. So now we are taking care of both the things and in a proper manner. So the model knows that, okay, I have to just show these videos to the user and don't show the negative videos to the user. And now when the model will eventually train, the answer that will come out to be will be like proper balance, where it will be showing the videos which are relevant to a particular user. Okay, this is quite understood here. But how are we even taking care of the point where you were saying that we are taking care of content based filtering, and how are we taking care of collaborative based filtering? Okay, let's think regarding this, that how this two tower neural network took care of both the things at the same time. How did it take care? Okay, so for content based filtering, it's pretty obvious that what will eventually happen is that we are just doing a dot product. So eventually what will happen is that so let's say this is video 1, this is video 2, this is regarding cute dog videos, and this is also regarding sweet dog or jumping dogs videos, something like that. Okay, so when the model trains, don't you think that for a particular user who has liked this cute dog video and the score for them was already high in our data set. Like let's say this user 1 has already lagged it and we already had a label of 1. Don't you think when the model will be eventually trained, this video 2 embedding vector will be close to video 1 embedding vector? So what does it mean? So consider that this is an embedding space, right? Consider that it's 233 dims. We were using 250 dims for representing a video. In that embedding space, these two video vectors will be closer to each other once the model trains. Yes or no? Okay. So if that is the case, it means that eventually if user 1 has liked this video 1, the score is high. So for if user 1 and video 2, it will be automatically recommended to user 1 because they both are close to each other. So the score would be eventually high. Right? So eventually we are able to solve one problem, that is content based filtering. Okay, but bhaiya, how it is going to solve the problem of collaborative based filtering, because we are not doing any dot product between user 1 and user 2. But if you think really closely, what eventually is going to happen when the whole model trains? Similar users will again have close vector representations of their user features in the embedding space. They will be also nearby to each other, user A and user B. Okay, so automatically what will happen is that all the users which are liking the same kind of stuff will be eventually near to each other, and you did not do any dot product between the users, right? But eventually the model brought them all together. So it solved the problem that if user A is liking a video and user A and user B are quite similar, then eventually they could be recommended each other's video. Okay, so eventually if user A is liking something as video 1 and user B is liking something as video 2, then the score between user A and video 2, user A dot video 2 will be also high, and same vice versa, user B and v1 will be also high. Okay, so it means that somehow we are able to tackle both the problems, that is content based filtering and collaborative based filtering. Okay, and the model also, we are quite sure what we are going to make. I just draw a simple diagram for you to understand that what will the model will look like. So it's just a 2-tower neural network where we have, let's say, user features coming in. This is a user based encoder, you can say, which gives me user embeddings. Same goes here, video features. It goes into a video encoder, video based encoder, which gives me video embeddings. And now we just do a dot product between them. We have a label at the end, and we eventually use a binary cross entropy loss for back propagation to make sure the embeddings that were generated are proper. Okay, so this model development part is over, but don't you think we need some evaluation for this model? So what should be the evaluation? Okay, let's think. Evaluation. See, whenever you make a model, you can't just make it online available to the users. You need some offline evaluation, and an online evaluation. Online evaluation means that let's say you made a model and you just did it live, everyone can use it. So how it will be taken care in the production, like how will you evaluate once the model is live? Okay, so there will be some matrices associated to it, but let's discuss it one by one, that what are the different matrices that are associated to it. Okay, so consider the fact for offline, the first matrix, very simple, precision at the rate k. What does this mean? What does this even mean? Let's say your company said that, hey, make me a recommendation system which generates 50 videos. Now you did all the model eventually, and you generated 50 videos on the home page, but the user said that for me, I 4 are the only ones which are relevant. So what will be precision at the rate k? It will be just 4 by 50, which is a really bad score. So it means that evaluation is like, this is one of the types of evaluation where you can say that, okay, the whatever model you have made is really bad in nature. Okay. Second thing, what other things which you can think of? Diversity. Okay, what does this diversity even mean? Let's say you open your feed and you just see dog videos. Throughout the feed you just see dog videos. Will you be happy seeing that feed? No. So the content should be diversified. It should not be uh, it should not be same. So we need some mechanism where we make sure that the content is also diversified. So let's say the user recommended 50 videos, and for every video we will have some video embeddings, right? So why can't we just let's say there are 50 videos, why can't we just take a cosine similarity between these videos? What does that mean? So let's say one could be compared with 2, 3, 4, 5, 6, 7, 8 and 50. Similarly, 2 could be compared with 3, 4, 5, 6, 7 until 50. 3 could be compared with 4, 5, 6, 7, and the scores can be generated. Let's say for first the score comes to be like 0.35. Again, for it comes to be 0.41. Some other score comes. And then what we do is that we'll just average all the scores together. So what do you think? When we average all the scores together, for a good model, the score should be less or score should be high? The score should be less. Why the score should be less? Okay, let's think about it. The score should be less because if the score is coming to be high, it means cosine similarity is coming to be high. So if cosine similarity is coming to be high, it means that the videos are quite related to each other, which is wrong. The content should be diversified. So it means that there should be like 2 videos which are of dogs, but again there should be 2 other videos which should be related to some stand-up comedy as well. It should not be just like 50 videos of dogs. So the score should be less in nature. Okay, so we understood, okay, these can be some 2 things which we can use for offline evaluation. But what could be done for online evaluation? Online evaluation means when the model is live. Okay, so when the model is live, the first thing is, let's say you showed 50 videos. What would you do seeing that 50 videos? First thing you see is the click-through rate. What does that mean? If 50 videos are shown to the user, how many videos are eventually being clicked also? So eventually if the says that 4 videos are only clicked out of 50, so it means that the relevant videos are not good for the user, right? It's bad. That should not have happened. Second should be like total watch time. So It's like, for example, if user opens it but even does not watch like for 10 minutes also, it means that it's really bad. Like whatever videos you are recommending are like really bad, not relevant to the user. Okay, what could be the third evaluation criteria? It should be like, it could be just like average watch time. So how much time does the user even spends over a video? Something like that. Uh, so all these three could be taken as an evaluation criteria, which and fourth, like the most important one, you always have a option of sending feedback to the video, right? You can even say that the video I does not dislike the video, or 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 you can just report the video. So let's say if user does this, what will eventually happen? So let's say there was this user one who disliked a video which was video 325. Whenever we trained the model, we thought that the user is going to like it and the similarity scores were coming really high. Now, in the next turn, whenever we train our model the next time, what we are going to do is that we will just make sure that the label for user 1 and video 325 is set to as 0. So this is a direct feedback to the model saying that, hey, improve this. Don't make this mistake. Okay. So this almost covers the online evaluation part. But eventually, how are we even going to serve this model to the all the users? Serving is quite critical. Like this is the most important part. Even the model development part is not important, because model development doesn't ensure that you are just going to use the same technique every time to just give the data. There has to be some techniques that have to be used to make sure that the final output should be really clear and relevant to the user. Okay, so the last part, that is serving of the model. See, our platform has 1 billion videos, and if we just take a single model, don't you think for single user comparing with like a billion videos, it would be just like really tough, and it would take a lot of time. We need to make sure that time also is really less. Okay, so why can't we just divide this serving of the model into two architectures where we use two models? Okay, what does this two models mean? What eventually they will do is how to even take care of that. Like you will have these questions. I'll just help you to clear out these questions. Okay, there could be one model which could be lighter in nature, whose work should be like out of billion videos. And if there are billion videos, and if a user comes, just give me like the top 10,000 videos, top 10k videos, or just the top 1,000 or 2,000 videos. Just think like that. Yeah, there should be one lighter model. And but for the lighter model, the accuracy doesn't matter. Accuracy does not matter. He has to just give me like 10k videos where there could be some false positives. Like, okay, he gave me a video which was not even relevant to the user, but still he gave. Okay, then in the later stages, we can use a heavier model. A heavier model which will take these 10k videos and will take the user and just give me like top 100 videos. Okay, and once these 100 videos are there, then we can just apply some business logic over it. Business logic means, for example, there could be like, if a user just watches a particular creator, for example, he just watches Carrie Minati, so it should not be like that all the 100 videos that are shot to the user are just of Carrie Minati. right? Even the content the Kariminati would give is diversified, but it should not happen, right? The max videos that could be shown for Kariminati is just two. So there could be some business logic required, and this is not a model. It's just business specific business knowledge, business logic that the business that the eventually the company will decide. Okay, these things need to be shown or these things not need to be shown. Okay, so but how are we? How does this lighter model and how does this heavier model look like? Let's see. Okay. So this lighter model is again just nothing but your two-tower neural network. Two-tower neural network. But it already has all the video embeddings saved with it. And this serving is just happening live, like it's just the inference that is happening. Okay, it's not the model training part. So already you have the video embeddings for every particular video, means for 1 billion videos you have all the video embeddings saved somewhere. Okay, and if a user comes, he is going to interact with this model. Okay, this is the user feature map, and the number of here we are going to make sure that to keep the model lighter, we will take less features of the user. Less features means taking age, gender, preferred language, maybe like the last top search history. Okay, just this stuff. And according to this, we will just do a dot product and apply this model, and eventually we will get all the top K videos out of this. Top K videos. Here K could be like from 1000 to 10,000. Okay, we have got this. This is a lighter model where we are not using all the features of user, neither the and video embeddings are already there with you. But we are just making sure the user features are really less. We are not taking all the user features. So eventually the model size is really less. Okay, and this will happen really fast. Okay. Then comes and this particular stuff is called as candidate generation. Candidate generation. Okay. Now, what will be the second model? The second model is nothing but the same stuff. Video embeddings for these 10K videos and this user feature map, again a two-tower neural network, nothing but a two-tower neural network. But here we are going to make sure that all the user features are there. All the user feature means every single thing that user has, what kind of videos the user likes, what comments he did, what shares he have done, what were the top 10 videos he watched, like the last 10 videos he watched, or what is the time at which he's coming online to watch this video. If it's the daytime, I need to show some music videos, and if it's like, let's say, night time, I want to show him some funny videos. Okay, something like that. So we will incorporate all the features that a particular user have, which will help us. So this will be again a heavier model, but again just a two-tower neural network, but will incorporate more features as compared to the lighter model. And this particular thing will be called as scoring. This service is called as scoring service. And the work of this scoring service is to give me just, like, let's say 100 videos. Now, once you get these 100 videos, the next task for you is to pass it to a re-ranking service. And re-ranking service is nothing but your business logic. And is this business logic a ML model or anything like that? No, it's not a ML model. It's just like some rules which are specified by the company to show. Just for example, show only like 2 videos of a creator, or show like let's say there are like 10 popular videos which are being recommended, just show 3 out of them, not all of them. So just pure business logic, nothing else. And once this is done, we can show the top 50 videos to the user. Okay, so this is quite clear to us. But how will the eventually diagram look like? Just let's form the final diagram of how the service look like. This is the user. Then this is a model for candidate generation. Here these are videos. The candidate generation happens. It gives videos. Then comes the scoring service, where again all the features of user also goes, and it gives like, let's say, 10,000 videos, and scoring service gives like the top 100 videos. And then there is this re-ranking service, which gives me the top 50 videos. Okay, till here I think everything is covered, but eventually you will have some doubts. The major doubt that I have seen is only one. Bhaiya, let's consider the fact that a new user has come up. What will you show him? And a new video has come up. How will you take care of that? Okay, so when a new user comes up, he logs in. What are the things that we know about the user? Age, gender, right? So we are quite sure that if we are aware about these things, there could be some categories which we can show to the user. For example, if the user's age is like 18 to 25 and he's a male candidate, then we can show him some WWE videos, some fighting videos, or some content which are like car racing in it, or some gaming content to it. Okay, so this can help us. Like just these two features can eventually help us to solve this problem of when a new user is coming up. And whenever, so what is this problem even known as? This is called as cold start problem. Cold start problem. Okay, for a new user, we are able to solve this problem that, okay, when he comes up, we can just take his age and gender. According to that, a feature vector is generated. And according to just that, we can just recommend him some videos, and whatever he likes or not, let's say he like few videos, then in few days, the model will be retrained on the new data set, and eventually he will see the relevant information. Okay, but what to do with a new video? See, there are two techniques of taking care of this. See, new video will have the title, tag, all the things associated to it. So in the video pre-embeddings, like whenever we said that we have video embeddings for every particular video, we know that two similar videos will be closer to each other. So it means that if user 1 is liking video 1 and if video 2 is closer to it, then we can even show this video to the user, video 2 to the user. So whenever a new video is coming in and we know that they are closer to each other, then eventually we can show v2 to the user, means new video to the user. Or what we can do is that, second thing is that sometimes if you see your feed is sometimes some random videos pop up. The same thing could be done with this new videos as well. So on a let's say on a different user, we can just show him a completely different video which he has not seen ever, which will eventually help us to understand that, okay, whether the user is even liking this video or user is not liking this video. Okay, so majorly, yes, we are able to solve this problem of video recommendation system, but yeah, how will we retrain this model and everything? What will eventually happen? See how it works in major companies, I'll tell you. So there is this lighter model, which is a candidate generation model. So this gets again, this is a very lighter model. So this could be retrained every, let's say, 2-3 days, every one day also. And with a new dataset. So what does this new dataset mean is that user came and he liked a video which he hasn't liked till now. So this is a new dataset that came up. So the whole model is retrained now according to what the user has liked. And then there's this heavier model, the scoring model. This could be retrained like within like 2-3 days according to the compute that the company has. Retrained within like 2-3 days. Bigger companies like train them after every 6-7 hours, but like the companies which doesn't have compute will eventually go for 2-3 days kind of stuff. So this is the whole stuff about video recommendation system. Thank you.